Good afternoon. This video is to explain some of the multiple choice questions from our challenge game today, the multiple choice, and we are going to do questions number 8, 6, 2, and 7. First question, number 8. This is asking you if you have a strongly skewed to the right distribution with a mean of 10 minutes and a standard deviation of 2, what's going to happen if you change all those into z-scores? Well, if you change things into z-scores, all z-scores that are standardized, that's what the z stands for, and it is the score minus the mean divided by the standard deviation, changes everything into a mean of 0 and a standard deviation of 1. So right now we can rule out A and B. Okay, so now we have the strongly right skewed to deal with. If something is strongly right skewed, then you are going to get a sample by taking different people one at a time. You will get also a strong right skew with the z-scores. So the correct answer is D. For number 6 was a bit of a trick, I have to say. First off, the mean is always equal to the median for any normal distribution. That's correct because a normal distribution has a single peak. Every symmetric bell-shaped distribution is normal. That is not correct. That is false. In order to test for normality, it has to pass our 4 tests. So you can have symmetric, semi-bell-shaped things that won't be normally distributed. The area under a normal curve is always 1, regardless of the mean and standard deviation. That is also false. The area under the standard normal curve is 1. And a standard normal curve will then have a mean of 0 and a standard deviation of 1. So number 4 is also false. And number 1 is false. A standard normal table can only be used with z-scores from a normal distribution. That's why we have our 4 tests for normality. So the correct answer for number 6 is E. Number 2, proportion of observations from a standard normal distribution that takes values larger than 0.75 is about. If you have a standard normal distribution, it has a mean of 0 and a standard deviation of 1. So if we have a value larger than 0.75, 0.75 is going to come down in here somewhere, and we're looking for this proportion. We know it has to be slightly bigger than 16 but less than a half, so we can cross out C, D, and E, and we can go look up that z-score, the probability that a z-score is bigger than 0.75. If you take a look on your table, which sadly I don't have to go to, but if we look at our table, 0.75 is at 0.8023 for this way. That's why they gave that last one as a distractor. But we want the other side, so we have to do 1 minus 0.8023. And when you do that, we end up with the number 0.1977, which is not an answer that we have. So somewhere, something went wrong. Let's see, the answer was supposed to be A. So perhaps I looked it up incorrectly. 0.7, yes I did. 0.75 is 7734. So we're going to do 0.7734 here. I completely apologize for the mix-up. I was looking at the wrong number. And finally, so if we do 1 minus 0.7734, we get 0.2266, which is in fact answer A. And the last one, number 7, the lifespan of all high school statistics textbooks is normally distributed with a mean of 9 years and a standard deviation of 2.5. So if we're going out there, we have 11.5, and then I believe we would get to 14 and 16.5 if we are adding our 2.5 on correctly. And we want to know more than 10 years. How many textbooks are going to last more than 10 years? So 10 comes down here. This is my X scale that I have up here. My Z score scale would be 0, 1, 2, 3. So I know my X value is 10. I now need to find out what Z value that is. So I'm going to use my formula for a Z score. 10 minus 9 divided by 2.5 is 1 divided by 2.5, and that equals 0.40. So I have a Z-score of 0.40, which fits in between 0 and 1 here, so I'm feeling pretty confident about that. When I go to look that up on the table, 0.0 or 0.40, I get to the left of that 0.6554. But that's not the way I want to go. I want the other way. So I'm going to do 1 minus 0.6554. And when I do that, I get 0.3446. And that answer is approximately 34.5%. To do this right up correctly, I would say the probability that a textbook is older than 10 years, or X is greater than 10, is the same as the probability that Z is greater than 0.4, and that is approximately 3446. That would be the correct notation. So those are the 4 most missed problems. For the other problems, if you want to see those, please view the class website and the slides for today, because the answer to all of the problems are handwritten on slides, it looks like 12, 13, 14, 15, 16, and 17 are the answers to the rest of the multiple choice.